Okay, I wanted everyone to see why we're fracking this zone in the ASE number 4. These are slides from the core that we took from that well in the prospective zone. You can see here a VUG, which is just a cavity created in the carbonate by water percolating through it in geologic time. You can see the big VUG here and a bunch of little ones surrounding it and other little ones in this slab. And you can see that this one is more than 10 millimeters or a centimeter large. So it would contain a lot of oil. However, there's also oil in all this matrix rock. If we look at this slide, you can see there's a bunch, again, a swarm of small little vugs or spaces in the rock that will contain oil. And these are little guys. These are just a millimeter in size, maybe 2 millimeters, and they're connected. Some of them are connected vug to vug, and some are connected to each other through the matrix. And in geologic time, the fluids can move easily from one open location to the other and still saturate the rock. If we look at this one, you can see again the size of the vugs. They're 2 and 3 millimeters in size. This is the depth of this particular slab is 3,978 feet. Now, the next slide will show you that same slab right here. There it is there, 3978. The reason it's glowing is because oil glows under ultraviolet light. And you can see this is saturated with oil in the matrix. The vugs actually don't have any oil in them because it drained out when we recovered the core and flushed it with the drilling fluids while it was being drilled, and then further flushed it when it got to the surface and the pressure was all released. So the oil drained out of the large spaces easily. The problem is this matrix is very tight. So we have to have either a large pressure drop to push it out, or we need some kind of chemical treatment. In our particular case, we're going to use the nanoactive particles to help release the oil and move towards the fracture and towards the wellbore. To give you another example of this, let's see, there we go. There is another very large vug. That one is, some of these are 2 centimeters across. Some of them that I don't have a picture of here, but some of them are big enough to put your thumb in. So, which are very large, and you rarely see those kinds of carbonates that are saturated with oil and are very vuggy like this. You rarely see that anymore because most of those reservoirs have already been found. That would be considered low-hanging fruit. In our particular case, we found a reservoir that we believe we can unlock and produce a significant amount of oil at very commercial rates. This same slab is in this slide, and that would be this one right here. $39.97, which is this one. And you can see there's those vugs, but there's nothing in them, okay, because they've been drained. But again, the whole matrix is saturated with oil. This is not as bright because this is lower in the reservoir, close to the water transition zone we've spoken about before. It just means that it's got a higher water saturation. It doesn't mean that there's no oil or that there's no productive oil or it's going to be 100% water. It just means it's got a higher saturation. We knew that was going to happen. It's evident on the cores. But I wanted you to see what it is we're trying to get out with the nanoactive or nanometer particles and why it's important to use it.